Oh, hello, good afternoon. Gracias. Okay, so my name is Rafal Kozik. I'm happy to be here to present the results for the SWAROG project, an ongoing Polish project. And together with the co-authors listed on the slide, I would like to present some tentative results. I'm from Poland, from Politechnika Bydgoska, which is Bydgoszcz University of Technology and Science. And this is joint paper with the Wrocław University of Science and Technology. Okay, so the agenda for my presentation is the following. So first I would like to give some context and explain the motivation behind the research. Then I will skip and give some brief details about the SWAROG project, the key goals and the motivation. Then I will skip to processing pipeline that we use for the fake news detection. Explain two phases of the project. So because we focus on English data sets, then we switch to Polish annotated data set, and we have our own approach for the annotation, which is intended to address some gaps and limitation of the English data sets. And I will give some conclusion and future works later on. So the motivation is the following. Modern world is full of data, it's obvious. And we need to face with abundant amount of data, information that we need to consume. And the truth is that we cannot validate everything. It is difficult. There is too much of information to process. And the human tendency is that we usually like or appreciate the content that looks visually appealing or appears to be relevant or intriguing. So unintentionally, this way can become the source of fake news, because we usually tend to resubmit, repost, retweet that kind of information which looks like interesting for us, and it looks like relevant. There are also some challenges and some factors that we need to consider. First of all, the media and social media and the traditional media has become an element of state security. So that's true. And this is mostly because during the COVID pandemic, we noticed that shift in the way how the traditional media works. So the journalists start to work remotely from the distance and started to rely on online sources. So for them, that was difficult to validate all the information they found online. Also, we noticed that the impact of the social media is huge, and we have this tendency that the non-expert is often as valid, as important as an expert. So the people who are influenced on the social media sometimes are more relevant than the experts. So the SWAROG project is a Polish ongoing research project. We focus on detecting fake news, on maybe not only fake news, but on analyzing the textual content in order to assess the credibility of the text. We have three phases. So we started in 2022. Right now we are in the second phase, and maybe hopefully we'll have the third phase. The consortium is quite small. We have three partners. So as I mentioned, Politechnika Wrocławska, our university, Politechnika Bydgoska, and a private company called Matic. So Wrocław University of Science and Technology is the technical leader. We are the partners, and Matic is some kind of coordinator that is responsible for the whole project. And I need to repeat or stress the fact that we only focus on the text. We have limited resources. We couldn't afford for focusing on video or images. Sorry, not that way. Okay, so the processing pipeline for the fake news detection for text analysis is the following. So we start with the data ingestion, and in different phases of the project, they look a bit different. I will explain this on the next slide. Then we have data normalization, so that we put all the data we have in some consistent way using similar formats so that we can use it for further processing and eventually for content classification. And at the end, we have some results, which is basically a prediction of the content, of what kind of content its credibility, and have some explanation. So maybe to visualize this, how this pipeline looks at the end is the following. So the user has some kind of graphical interface. She or he can put some query, some text to analysis. He gets the classification. So right now it's like true or fake, and have some probability or how certain the classification is. We predict the category, and there are several categories like COVID-related, health-related, political news, and that kind of stuff. Some keywords that help the user to understand or comprehend the content of the document. And last but not least, we also try to find something similar to the text the user put in the query, and also try to match the similar blocks of text in the analyzed text. So the data ingestion for the Polish media is the following. So we couldn't find any relevant data set that is annotated. So we needed to develop our own. So we have created different crawlers that collected the data, and then we normalized the data, and finally start working on the content, on the textual content, to develop some text credibility classifiers. For the English, because as I mentioned, the first phase of the project was focused on the English data sets. Right now we switch to Polish. So the English data sets, we try to collect as many as possible data sets. So probably we reached the most of them. And they could be roughly categorized as political data sets, health-related, news, COVID-related, and that kind of stuff. And they are diverse in the sense of the size, and also diverse in the how specific data samples are big. So they are short sentences, they are longer text, and so on and so forth. As for the content classification, and this is for the English part, so I forgot to say that mostly the English data set, they rely on binary classification. So we have labeled like this piece of text is true, this piece of text is fake. So this is the reason why we, at the end of the classification pipeline, we have binary classification. So we try to say, okay, this is true news with some confidence level. Like here. Actually, we rely heavily on transformers, and here we have the actually ensemble of classifiers. So for different categories, like for COVID-related, we have specific transformer that categorize the content as a true or fake. We also recently used this trick to embed and then the neighborhood, in the sense that sometimes we have short sentences. Like in this example, we have the sentence that the COVID has been created in lab, and the following sentence that it has not been artificially created. This sentence, these two opinions are close to each other because they are concerning the same topic. And this way we can build some additional feature vectors that allows us to further boost the performance, but this is some kind of work we are currently focusing on. As for the results for the English dataset, because we mostly analyze the benchmark datasets, we have been able to reach or in some cases surpass the state-of-the-art solutions. Shortly summarize them. There are some easy to cope with datasets, but some datasets are more challenging, like the liar dataset. We wouldn't be able to achieve higher than 64% of average F1 score. In the paper, we also have compared the proposed method with other techniques, so more details you can find in the paper. But the key message coming from this analysis was that we may find some limitation of the existing annotation procedures. So most of them are limited to binary classification. The second fact is that there exist data sets that use the batch annotation, which is not accurate, and there's the discrete bias due to this true or fake binarization or classification approach. Also, what is important, we don't know much about the expert who annotated those data sets, so we don't know how old are they, what are their political views or opinions, and stuff like that. So that's the limitation that we found. Therefore, the Wrocław University of Technology have developed their strategy for annotating, and in order to do that, they have collected the almost 500,000 of records over 1 year from almost 48 internet portals from 2021 to 2022. So what have been collected mostly text and some relevant metadata, such as when the news has been published, when it has been updated, who is the author, and that kind of thing. Is very, very useful additional data that, apart from the title, obviously, and apart from the content. The thing is that submitting almost 500,000 of news for the annotator is very expensive. We have been limited. We needed to limit the data set to 40,000, and submitted that kind of annotation package to the annotator. And in order to do that, there was dedicated procedure to ensure that news are evenly distributed among the sources. Annotation process, okay, so details about, I would like to give some details about the annotation process. So we don't ask a binary question in the sense that is this news fake or not, but rather we apply the multi-factor concept. So there are 13 questions about the text that the annotator is reading, and they are roughly grouped into 3 categories. So one is for verification, one is for manipulation, and metaphysical factors. And I try to put everything on one slide. So verification factors actually ask about is this source credible? Are you able to find some credible sources that support the material you are reading, and so on and so forth. As for manipulation, the question asks if you think that the author is using cherry picking or intentionally try to mislead you in the text, and etc. As for the metaphysical stuff, the questions are focused on the content, asking if it's religious content, political promise, or something that is satirical. And also, because it is worth mentioning that there are no single answer for this question for a specific news. We also asked the annotator for another specific question about his political preferences, about his social activism, and if he or she is using social media. That kind of stuff would be helpful further on during the classification process. Roughly summarizing, you can find more details in the paper, obviously, but summarizing the stuff that has been collected in two features is that the annotation process shows that we have a broad group of annotators, ranging in the sense of age, gender, as well as the place of residence, and political and social activity. Also, between the age and the use of a social media, this kind of stuff could be obvious. I mean, obviously, older people don't use as much social media as the younger one, but this also helps us to identify the data set is relevant in the sense of its quality. So There are in the questionnaire there are some intentional questions that if you, for instance, select true for one question, then you need to select false. It also helps us to identify that the person actually read the questionnaire. Okay, jumping to conclusion. I presented some tentative work for the SWAROG project. We haven't developed any significant method for the Polish data set. This is happening right now. At the moment where we submitted the paper, we have in the beginning phases of analyzing the data sets. As for the English, we have more than 14 gigabytes and over 1 million unique documents, and using this knowledge we came up with, as a consortium obviously, to the specific annotation procedure that is intended to address the limitation of English dataset annotation process, mainly because they are binary. I mean, the labels are binary as true or false, and here we have more complex schema. And for the Polish data set, we have right now 40,000 annotated documents, and the analysis for Polish are in progress. So that's pretty much it, and I would like to again thank you all the contributors, especially the Wrocław University of Science and Technology, and all the partners in the consortium, so that this research can happen. Okay, thank you.